All right, good evening, everyone, and thanks for coming in. So we are super excited because we rarely have so many RSVPs on Meetup than for today. So this must be a great event. And the schedule is packed. You will see so many people on stage that with the intro and the whole housekeeping, I will try to be super, super fast, okay? So most important thing is that the toilets are in the lobby. They are a little bit hidden inside the wall, but you will find them if you need them. And I'm Zoltan, by the way, one of the organizers of this meetup, and Wolfgang, our chairman from Vienna Data Science Group, right here. So the agenda today is we have basically two blocks. We will have a talk from AI Factory Austria. We'll start with Markus, the co-lead of AI Factory Austria, and then Ann-Sophie and Mara will present about the whole concept, and then Marian will continue with a connecting use case. Now, after that, you will hear a presentation from Paul from Mostly AI, who will show you how you can use synthetic data to create data sets similar to the real world. This is basically what we have, and at the beginning we have a sponsor talk, and as always at the end we're going to have an open mic, so for those of you who submitted slides you will be able to present them. And we have one copy of our book here in German, which will be referred out. But as you live in Austria, probably you either speak German or you will speak German. Yeah, and that's it. We'll try to go without a break. So again, I'll try to be super quick. Quick intro of Vienna Data Science Group. So as many of you know, and let me just go with Wolfgang's usual question, how many of you are here for the first time? Can I get a raise of hands? All right, that's like more than 50% or around 50, so welcome. So Vienna Data Science Group is a non-profit verein in Austria, and our goal is to create a community for data scientists, data engineers, and everyone around data. What we do is that we organize one of the largest meetups, at least one of the largest independent meetups in Europe, and what you will see is that we have these meetup events and also workshops and also get-togethers. So if you are on the meetup already, which you are, then you are at the right place. We advertise most of what we do there, but we would also encourage you to follow us on LinkedIn, which is our main channel. So we have a book, more on that later. And if you want to support us, if you're a company and you can host an event, so provide a location, we are very grateful for that, so we can organize our meetups. Or if you can chip in with catering, that's even more important. And you can become a sponsor for VDSG. But if you are independent of where you work, if you want to speak, just come to us and we will find a slot if you have a compelling use case. So we are here for the community. Whoops, sorry. Oh, that's Wolfgang. I just continue here, all right? So from the VDSG board, there are 3 people here. So I'm here, obviously, and Wolfgang, and we have Georg Heiler. Georg Heiler is right there. So if you want to talk with us, just come and talk to us. And we also have a yearly membership. So this is not for the meetups. Meetups are always free, but sometimes we don't have sponsors for catering, so we cover that ourselves. So if you want to chip in, it's a great time to become a member. And the member comes with a few benefits. And by the way, there are a few QR codes on the walls if you want to become a member. And that's like a VDSG email address. And of course, you can put on your CV that you're a Vienna Data Science Group member, which is like a fancy thing if you're applying for a job. And we have discounts for conferences, discounts, but actually free online courses. Oh yeah, I have this here. And a few other things that we can provide you if you join. So that's very much it for us, and I would like to give it up to our sponsors, Cloudera, Init, and AI Factory Austria. So yeah, thanks so much for having us here. Without you, we couldn't run this event, so we are very, very grateful. And I think that's very much it. Again, follow us on LinkedIn. And then our first talk is from Andreas from Cloudera.
I'm just here to say a very big welcome to all who have came here to TU Wien. The room was organized by, on the one hand, Init, on the other hand, of the AI Factory, what you will hear about a little bit in more detail by my colleagues Mara and Ann-Sophie. And I'm just would really like to have such events to reach out to the community and see what is going on and learn and connect to the people, because this is on the one hand the mission for the Init when it comes to startups and the AI Factory, when it comes to any AI topic, as you will learn in a second. So if there are any questions, just reach out to us. I and my colleagues will be around after the talk and when everything is finished, and we will have some drinks and something to eat. Yeah? So have a nice impression of what we see now and the talks which will follow up. Yeah?
Thank you.
Thank you, Markus. Hello, everyone, and a warm welcome from our side. As already introduced, this is Mara, I'm Ann-Sophie, and we're from the AI Factory. And we're happy to be here today to present you what the AI Factory does. This is our agenda. We start with a snapshot on the AI Factory, and then we would like to give you an overview about the Austrian AI ecosystem and show you the important players and stakeholders you might already know. The next one, the AI strategies. We start with the Austrian AI strategy, give you a quick overview, and then one level higher, we will show you what the European AI strategy contains. Afterwards, there will be an exemplary project presentation by Marian, and he will show you what he has done with the HPC. Let's start with the first one, the Austrian AI Factory. We are the flagship initiative for turning the national AI strategy into action. Our goal is to create one central hub, one-stop shop, that's how we call it, for AI innovation. Moreover, we will provide supercomputing infrastructure and also one central hub, so an open and cross-sector hub where all people can come together, connect, and talk about AI-related topics. Moreover, we will support in AI projects, first on a business side, but also on a technical perspective. And what we always want to focus on is the trustworthy AI. Here you see our consortium. We have two leading partners. It's on the left side. It's the AKA and the AIT. But also Mara and I, we're from Init, and we have also people involved, and the ÖAW is also sending people. So you see us as affiliated entities, and the other logos, these are also often universities also supporting the AI Factory. Regarding the funding, it is a 50-50% funding from a European and from a national level. On the left side, you see the European, and on the right side, you see that Austria has supported with the Ministry for Innovation and also the FFG. And now we're already coming to the second point, the Austrian AI ecosystem, and Mara is giving you a brief overview about the most important players.
Thank you, Ann-Sophie. I'm also happy to be here today and to give you a little bit of an overview about the AI ecosystem. We looked at it, and what we found is that it has about 450 AI ecosystem players. They are made up of about 120 companies that have AI as their core product, about 160 startups, about 80 ecosystem enablers. These are entities such as the AI Factory, about 50 universities and research institutions, and about 40 investors and public funding institutions. When we looked at the startups even more closely, we found that there's a lot of growth happening, about 10% annually. We also found that about 50% of them, more than 50% of them, receive public funding. This, on one hand, this is of course really good because it means that Austria is very supportive of the AI ecosystem. On the other hand, it also definitely means that we have a need for venture capital investment. We also found that about 60% of them are located in Vienna. However, of course, there's also other regions with a very thriving AI ecosystem, such as in Styria or also in Upper Austria. And here you see some of the focus topics also. And then, of course, there's a lot happening in the whole country. These are just some of the highlights. To give you a bit better of an overview about the different actors, I structured it into 3 layers. So here we have the first layer, which is the governance and funding layer, which is kind of the basis for everything that is happening. This is the public sector, policy, and the funding. Next, we'll talk about the foundations and infrastructure. This is the universities and academia, as well as the actual infrastructure. And then lastly, we'll talk a bit about the industry and the community, the startups, the networking, and the communities. So starting with the public sector and policy, that of course in Austria is the Federal Chancellery, as well as the Ministry of Innovation. And the way they come up with the AI strategy is through a system of 4 players, which is a lot of people from the AI ecosystem that function in like an advisory capacity. That is the KI Beirat, the AI Policy Forum, the AI Stakeholder Forum, and the KI Servicestelle. And then the Digital Austria platform that most of you are probably familiar with is often used to implement a lot of these digitization efforts. Next, we're looking at some of the funding programs. Very well known on a national level is, of course, the FFG and also the AWS. To give some examples, we continue on a regional level. Again, these are just some examples, okay? So this is definitely not a 100% cohesive list, but basically you can see that every state has their own funding program, like the Vienna Business Agency or also Innovation Salzburg. Everyone in each state has their own AI initiatives. And last but not least, we're looking at the European programs here. I'm sure a lot of you are familiar with. These are programs such as Horizon Europe or the European Innovation Council. Thank you. So next, we're looking at the second layer. This is the infrastructure layer and the backbone for AI in Austria, as well as the research and academia. This is where all the innovation and the knowledge actually stems from. And here we have the infrastructure slide, which is also where we put ourselves as AI Factory. Here at the beginning, you see the European Digital Innovation Hubs and Networks and the EuroCC. The EuroCC is one of the predecessor programs of the AI Factory. They both don't have their own infrastructure, but they are both enablers of getting to HPC infrastructure, while the 3 things you see on the right side is the Vienna Scientific Cluster, the Euro-HPC Joint Undertaking, which is the program that the AI Factory is also a part of, and you will hear a bit more about the different HPC systems here later, and us as AI Factory. We all have our own HPC infrastructure. Next to research and academia, here you see some of the greatest universities in the country when it comes to AI and technology, but of course also things like the Austrian Research Institute for AI or the Bilateral AI, which is a cluster of excellence of some of the universities that work together. Last but not least, we have the last slide, industry and community. Here, very obvious, startups, industry, networks, and community. So to get started with the startups and industry, we clustered it into startups, companies, early adopters, and international players. And as I mentioned earlier, we found that there's about 160 AI startups in Austria that have AI as their proper core competency. And we see here again that there's a very vibrant early stage startup scene. As I was saying earlier, there's a lot of funding, public funding available, but also public funding only goes that far, and this is when the venture capital funding would be needed, which we see as a little bit of lacking, which leads to limited scaling up, which leads to there to be also less of a number of mature AI companies and scale-up companies. However, of course, there are some really great leaders that have done the jump, such as, for example, Mostly AI. I want to highlight here, they're going to talk later, and they, of course, started out as a startup, but can now be considered a scale-up. As for the early adopters, we found that there's about 150 of them, and we found that the Austrian corporates are on par with the European average, while the SMEs are slightly below, and there's slightly lack in adoption. And last but not least, the international players. Here we were only able to identify about 30, which shows that there's still a lot to be done in this field, but this also is a great opportunity to attract more R&D and more international investment. Next, we're looking at the networks and communities. Here we have players such as the Austrian Society for Artificial Intelligence, AI Austria, and Women in AI. And of course, also the Vienna Data Science Group, which is the reason that we are all here. And I would actually also see us as AI Factory technically also on this slide in the future, because we are more than just the HPC infrastructure. We do also really want to build community. So just imagine it's here also. And then next, the AI events. So here are just some examples of events that are happening in Austria that have a focus on AI. As AI Factory, we of course hope to be part of all of them in some capacity. Recently, we were at the IEEE, and soon we're going to be at the Now Business Days. So if anyone's there, we're happy to talk to you. So looking at this ecosystem, and also talking to a lot of already very active players in the Austrian ecosystem, we were able to identify 5 challenges that the Austrian ecosystem has. A lot of them I mentioned already, but it's the insufficient investment. All of these also sort of correlate with each other, because of course the insufficient investment leads us to limited scalability, which leads to a talent drain, and then also the slow market adoption I already mentioned earlier, and all of this together obviously leads to a lack of trust into the AI ecosystem. But of course, Austria is very aware of this, such as is Europe. So they have implemented, or they came up with a strategy that they're currently also implementing to tackle these challenges and to make us, as Austria and also Europe, as places at the forefront of AI. And yeah, now Ann-Sophie will give you a bit more of an overview into the different strategies.
Yes. Let's start with the Austrian AI strategy. Here you can see the vision. It's very important to know that the Austrian AI strategy is based on the European values. So they highlight and want to secure fundamental human rights like equality, also like privacy, data privacy, as we all know. The goal of the Austrian AI strategy is to strengthen the role of Austria as a hub or a central place for AI, for research, innovation, industry. So to bring also these groups together in regards of AI. Let's go a little bit deeper than just the vision. Here you see on the right side, it's the document of the Austrian AI strategy. It was written or developed in 2021, and it was developed by more than 160 experts from various fields. It's coordinated, of course, by the Federal Ministry for Innovation and Technology. What's important to remember here is that it is always based on 2 pillars. The one is the trustworthy AI, and the other one is the creation of this AI ecosystem. There are 3 objectives. First, it is that AI should be used for a common good. Second, that Austria should be recognized, even internationally recognized, as a location for research and innovation. And the third goal that you can find in the Austrian AI strategy is to secure the competitiveness of Austria, and again here in the field of technology and also as a business location. But since 2021 is already a long time ago. They came up last year with an implementation plan, so with an updated version. So in case you want to read about it and go a little bit deeper, I would recommend you to rather read this document. Also here, 12 ministries, so all of them were involved, and they came up with 91 concrete measures, what they want to do in Austria to secure that AI is implemented as fast as possible and in a trustworthy and correct way. Here again, you see the two goals, trustworthy, so what do they mean by that? They want to ensure that the ethical standards and the regulatory rules are well implemented and respected, that there are standards established, and the security aspect is again highlighted here. On the other side, the AI ecosystem, it's about bringing together the expertise and ensuring that data and knowledge on AI is exchanged in Austria, and also ensuring an infrastructure here on a technical level. We're coming to the HPC in a second. And also the third aspect is important, skills and training, so enhancing the AI understanding within companies and within all areas, basically. Coming to the European AI strategy, so now we're going one level higher. It is well aligned, the Austrian and the European, which is great. So here again, you see it's pretty similar. The first one, investment and innovation. They want to enhance and support that there is public and private investments into AI, and that this topic is important to the ecosystem. The second one, the infrastructure, here it's about the HPC clusters that Europe wants to provide. Here also it belongs to the AI factories in Europe, but also the gigafactories coming. So there's a lot of focus in providing the infrastructure needed to enhance AI on a European level. The third one, skills and education. It's about supporting and increasing the knowledge in research and innovation. So also supporting experts in that field. It's about getting experts, but also retaining them in Europe and not losing them. And third, also an aspect is to upskill the people to make them able to use AI in the correct way. And the last one, regulation and ethics. Again, here it's the aspect with the European values and the European rights. And how do they want to implement it? Here there are two important plans to remember. It's the AI Continent Action Plan, with the goal to position the EU as the leading AI continent. And here in bullet points, you see how they want to do that. They want to offer the computing infrastructure, access to data. They want to accelerate AI adoption, especially in strategic relevant fields. They want to increase the AI talent that's available in Europe, and they want to ensure that the regulation is effective, but also simplified, and more simplified than other things here in Europe. On the right side, startup and scale-up strategy. Here again, Europe also wants to support by doing, you see the bullet points, by closing the funding gap, which Mara has mentioned before, by strengthening the innovation ecosystem, by also attracting and retaining the top talents within Europe, and by supporting with this simplified regulation and make the market entry and the market access easier to them. And how do they want to do that? It's of course also with the AI factories, and currently there are 19. There has been 3 rounds. The first one you see on the left. These are the first 7 AI factories. Then the second round, here you see also the AI Factory of Austria. We were part of the second round. And then just a few weeks ago, there was published that there is a third round of AI factories, and this is the one on the bottom. And you see the investment is very, very high. So that's a great sign of Europe to really take this topic of AI in Europe seriously. And now you have the overview about the strategies, and now let's go deeper into what we, as the Austrian AI Factory, plan to offer.
Great. Okay, so let's dive deeper into the Austrian AI Factory. As we already mentioned, a lot of times now we are part of the European joint undertaking. Those are the slides you saw earlier with the different AI factories. and we aim to provide cutting-edge infrastructure and expertise for AI research and development. We keep saying that we want to be a one-stop shop for everything in AI, which I know sounds a little bit vague, so I'm going to try to explain it to you a little bit better with the services that we are offering. Even though I will admit also those sound a little bit vague, so I will go through them. I want to preface this by saying that we are just finishing our ramp-up phase, so hopefully in the next weeks it will become more clearer, so feel free to talk to us about it. It will be on the website soon. So the services that we do want to cover though are in the fields of advisory and customer care, AI infrastructure and platform access, AI innovation services, AI and data implementation services, training and skills development, as well as ethics, compliance, and regulation. So it's a whole lot. But the two services that I do really want to highlight is that we are planning on having a physical hub that is supposed to be a meeting point for the network and the community, and a physical one-stop shop where everyone should get together. We will offer co-working spaces. So it will be like if you are active in AI and in the ecosystem, it will be possible for you to rent a desk or to rent an office or to host our event with us, and all of this will be for free. So that's good. It's always better than if it has a cost. And then also for networking collaboration, as we said earlier, we do really want to just strengthen the Austrian AI community and network. We don't want to double on anything that is already existing. We just want to create synergies, and so we are very open to hearing about everything that you're already doing and to just see what holes we can kind of cover and how we can assist. And the second point that has already been obviously highlighted a lot is the supercomputing infrastructure optimized for AI. Earlier you saw some of the other AI factories. Our GPU-based European supercomputer will come in 2027, but and it will be open to everyone. It will be open again to the whole ecosystem, startups, corporates, research institutions, the public. But do not worry, we still already have the infrastructure, just not the physical one here, and you will hear about it now.
Here, great. On the next slide, you see that the AI-optimized supercomputer should contain more than 600 GPUs. Also, if you're interested in some of the metrics like cooling method or power consumption, you can see them on the right side. Then here you see the Euro HPC system overview. Here the blue ones are the one with the AI Factory access. And that's what Mara mentioned. The Austrian supercomputer coming in 2027, that's no problem, because until then we will use the one in Italy, the Leonardo, standing in Bologna. So we're covered with the capacity for supercomputer until then. And here again you see our key sectors. The target group is the Austrian key industries, SMEs and startups. The key sectors like biotechnology, manufacturing, public administration, physics. We mentioned them, but here we also mention for others because we are, as Mara already mentioned, open for all kinds of sectors, and there is no decision on whether you can enter or not based on the sectors. So free for everyone. And then here, last slide, our timeline. We just finished our ramp-up phase, and we are currently in the launch of our first operational services. So that's why our service offering will become clearer day by day. And beginning of next year, the co-working will start. And here we hope to welcome as many people as possible from the AI ecosystem. And then beginning of 2027, we want to welcome the supercomputer. And now we'd like to hand over to Marian, giving an exemplary project insight on how he and his company have used the HPC cluster. Thank you.
Okay. Now it works. Yeah, hello. My name is Marian Lux. I present now the already finished project 23 days ago. It's called Cloud Shading AI. And if you want more information, you can scan this QR code or take a picture. Some words about me and my companies. It was my project, Cloud Shading AI, was an FFG, public funded project. It was performed by the company Lux Active, where I'm CEO and shareholder. It's a profit-oriented company. Here we do platform development and service development. One of our most prominent products is OHA, which has about 8,000 new users per month. And here tourists can book activities when they are on the spot. And I'm also CEO and shareholder of the company SWISDATA, which is a non-profit research center with the focus of the development of novel AI technologies. Here we do lots of research, and I have a third role. I'm also in the teaching at the University of Vienna. I teach mostly bachelor thesis, and if we do such innovative new research projects, I always try to bring this knowledge back to the students. And they can also test out new things, which helps our company, SWISDATA. And yeah, both companies are located in Vienna. Lux Active is a little bit older. It exists now more than 10 years. We have 6 people, and SWISDATA has 3 people and was founded in 2019. So to the Cloud Shading AI project. Here we used heavily the HPC resources. I will show later on. The goal was or is, where we have already developed the service, is a shadow forecast for 15 minutes up to 6 hours. And the project was together with the company Medgis, which is a meteorological IT company, and it was funded by the FFG. And the main target here was to help with the energy grid stability for solar power. So to use it as planning tool, this service. And here we combined ultra-high resolution terrain data together with Earth's observation data from the European Space Agency. And also weather data was used, which was prepared by Medgis. And we developed 2 services which are combined. I show later with a small demo. The first one is a terrain shading service where we use the sunlight and make pixel-precise calculations or predictions of the shadow from the terrain, for the terrain. And we also developed a cloud shading service by using many small AI models, where this technology is beyond the computing of only the visual flow of clouds. And it combines also the weather data with motion vector data. So before this project, the current state of the art was that other solutions just using cloud images consider RGB images rather than satellite data arrays. The AI models are mostly CNNs, which predict for the whole image. So they get an input and make this image prediction with an CNN. And the previous image is then used to predict the new cloud image. And movement vectors are extracted only by using the optical flow. And the movement is directly applied to an image, which is basically the output. And we went in a different and more advanced direction. We used satellite data of clouds instead of just images. We used, for example, the cloud optical thickness, which is the light transmission from a cloud, and we got per pixel a value. And also we used the cloud top pressure, which is the height, and there we also got per value a pixel. And then we splitted also the data into predefined vertical layers, because each layer has different winds, so for the clouds, for the motion. And then we used many small feed-forward neural networks, where we did the split for these many small networks from different areas by location and topography. Topography you can consider if there's lots of water or there are deserts or lots of mountains, because then we have different cloud movements in these areas. And yes, each group had then its own model, and then we applied the predicted movement. So the models predict the vectors and not the images. And then we applied these vectors for each pixel on such an image. And then we got the new cloud shading prediction. And here are some statistics for the execution of such a prediction. For example, if I take the 6-hour prediction, it has a runtime from about 5 to 15 minutes, and we have a space usage of 5.6 gigabyte. And the shadow accuracy from our service from this cloud prediction is 93% on average. Here we did an observation from about 400 data points from Austria in the month January. But the accuracy decreases based on the prediction time in the future, which is shown here. This is an internal evaluation picture we did during this project. Here we compare, for example, a 50-minute prediction with a 2-hour prediction. The black spots show the observed clouds, and the green are the predicted clouds. And what you can see on a 50-minute prediction, we have a nearly identical coverage, but on a 2-hour prediction, it gets a little bit worse. During the development, we heavily used the HPC resources, because when you are developing AI models, you know maybe if you do small adjustments, you have to retrain the whole model. And this takes time, and especially during the development, you test out many different things. And that's why the HPC hardware saved our development time tremendously. And we trained, as I said before, multiple small AI models in parallel. And the training was on one GPU. It was a A100 with 64 gigabyte VRAM. We got the Leonardo HPC resource. And here we we used multiple processes in parallel, and each process trains one model. And our approach to get to these resources, our process was the following. First, we went to the AI Factory Access course website. It's an EU platform. Then we selected the core. We did we wrote the proposal. We are very skilled in writing proposal, so it took about not more than 2 hours. And within 2 days, we got the positive confirmation. Then we did a user registration where you have to also upload your passport for all the users who want to work actually with this cloud infrastructure. And after that, we got the access and could start using the resources right away. And yeah, our feedback, what was positive, the support from EuroCC and the ASC was really good. All our questions were answered immediately. We also had meetings, online meetings, if we needed them. Yeah, we got fast and easy access to the resources. The code ran on the HPC cluster without any changes. Yeah, it had the same dependencies. We didn't have to write extra code. And the job submission via Slurm was also good, documented, and it was also easy to use. But we were very experienced with this because we had already trainings in our team. And it was also easy to upload our data with rsync. And yeah, the downsides were there exists a maximum execution time for one job. So we had to implement, or we were forced to save the state for continuing the job later on. And yeah, also what surprised us was the CPUs. They were a little bit older than our local CPUs, so everything took longer. And we needed the CPU for the data preparation processing, also pre-processing of our data. And yeah, there is also, could be an improvement in the general documentation. Interesting sections were hard to find, and there was also missing information how the software actually runs. Are there containers? Is there a shared system? How is the access? Is there just a web access or an SSH access? Yeah, but we figured everything out. Yeah, now I will show you two demos. This demo you can also try out yourself. It works 2 hours, 3 days in future and in the past. And for this particular date with this time, you can also use the cloud shading service. And yeah, let's show. Here's my mouse. Okay. Here we have the terrain shading, and if I go forward with the time, you can see the shadows, and then I can also enter the cloud shadows, which is now very dark here. I can go here, and here you can see the different light transmission. And this is also available via API. And another demo from our partner, from MedGIS, they provide, for example, a 3D view. Here we have mountains, we have also the terrain shading. And this goes, for example, beyond the use case I introduced at the beginning for the energy domain. You can use this, for example, if you plan your hiking trip. This can be used, for example, in the tourism domain. Yes. And finally, yeah, how to connect with us or what we can offer to you. You can just enter SWISDATA EU contact. We are really experienced in working on national and international public funded projects. We have a widespreading network across Europe. We also acted and act as lead partner and always as technical partner in such huge consortiums. We have recently finished an Horizon 2020 project where we were the lead partner, which got 50 million euros from the European Commission. So yeah, we have experience in this part, and SWISDATA is also an official research partner for the FFG Innovation Voucher. If you don't know this, if you have an idea, your company is from Austria, you want to go beyond state of the art and want to do something with AI, large language models, etc., then you can contact us. You can apply for this innovation voucher. You pay 2,500 euros. You get 10,000 euros from the FFG, and you receive services from SWISDATA with a value of 12,500 euros. Yeah, and what we also provide is we can help you with the HPC cluster usage. We can evaluate your use case on a technical perspective, and we can also optimize your use case with available resources. And yeah, what we also provide is this API from the Cloud Shading AI, which I showed you. Yes, then I hand over. Thank you.
Thank you, Marian.
Thank you.
Yeah, so thank you for giving It's okay, because I talk really loud. Okay, it's fine. Okay. Thank you for giving a good example of a project. And this is one of the ways that you can cooperate with us as AI Factory. We will happily guide you through the process of applying to the HPC infrastructure and also supplying the HPC infrastructure. But of course, there's many other ways apart from the supercomputing power, as we mentioned. There will be business trainings, there will be technical trainings, co-working, and most importantly, or not most important, it's all important, but the community aspect. We're just really happy to collaborate and open to hearing all of your ideas and ways that we could do that together. And yeah, so if there's any questions or any ideas or anything, please do feel free to reach out. I don't have the clicker, but here. Thank you so much.
Thank you so much. Well, exciting times. There are still some time for questions, so if you folks want to get back to stage. So, Mara, Ann-Sophie, Marianne, would you like to come back to stage for a few questions, if there are any? Yes.
Hello, hello. Thank you for the presentation. Just for the record, right? 2030 will be the year when the capacity will be in full place, right? How many gigawatt of power gonna be there?
You mean for supercomputing?
Yeah, like for GPUs,
Yeah,
right?
do you want? Yeah.
Okay, so
Yeah.
Or maybe for the Europe in
come.
total.
in total, this I don't know. I can just tell you about the planned infrastructure in Austria. This is we will get, as shown, approximately 650 to 700 GPUs. And the total power usage that we assume that will be there is around 1.5 megawatt. It will be hosted at Arsenal, where the other supercomputers are. But these are the numbers that we are talking about. The systems which are installed, especially in Finland, Lumi and Leonardo, and what else do we have? In France and so on, they will be about a factor 10 times larger, so you can do the math yourselves, because the hardware is, let's say, very similar, and the power consumption will also be very similar. But actually, we could do some research probably to find that out, but I don't have the number right at hand now for that purpose. Yeah.
Next question. I think you were first, and then.
Yeah, thank you for the talk. I would like to ask, in terms of the cloud prediction, was there, the process seemed very cut and dry from how you showed it, but did you go other routes before that? Because separating it into different wind layers and how you approached it, like, was the process a bit longer than that behind, or were you experts or knowledgeable about how this works?
You mean from the state of the art to our solution?
Yes.
No, yes, we had many trial and errors. We did research first, and it showed that there was no solution public available. I'm not sure. I think there are companies who do maybe similar things, but there's no official paper which shows our approach. We are also considering to publish a paper on this. And no, it was not straightforward, yeah. But the HPC resources helped us extremely because we were much faster in our trials, yeah.
So you could do more experiments and try
yes.
it out. Okay.
Yeah.
Yeah. Thank you.
Welcome.
Hi. Thank you for your talk. In terms of the cloud prediction, I wanted to ask you, you mentioned you used CNNs as your AI method. Is there a reason for using CNN?
We didn't use we didn't use CNNs. This was I showed this. This was the state of the art because other solutions just use the image and predict the next image, the next cloud movement. And then if you do something just with images, then the most obvious solution is, or the most obvious network you try is in CNN. But we used feed-forward neural networks. We just extracted the movement vectors, and then we applied it on those images, on the pixels. Sorry.
Okay, and
yeah. But we didn't use CNNs. We tested them at the beginning, but yeah, there was no.
Did you also use transformers by any chance?
No, we were considering to use transformers because you can use transformers everywhere. But yeah, we got this high accuracy with this approach, with the simple feed-forward neural network, and we didn't want to overcomplicate it. Yeah.
Okay, thank you.
Thank you. Another question? Yeah, sorry, now, just to be fair, I'll pick someone from here.
Thank you very much for the talk and the interesting topic of cloud shadow forecasting. So my question is, what verifications did you try to verify the prediction of clouds or cloud shadows? I mean, against what kind of observation? You showed an image, but what kind of observation or satellite products you used?
You mean the evaluation? What we did for the evaluation? Mostly we did this evaluation based on the images I showed before, and we did this also programmatically. But because we had, if you do this in the past, you can see how the cloud actually moved then. And then you can compare it. We have this, as you have seen, we have this green and black spot, and then you can look if there is a coverage.
And just for curiosity, what kind of satellite products? Of course, satellite products. But what kind of satellite products did you try to compare? I mean, METOP or like MSG, etc.
Yeah, it was a MSG version 2, I guess. Yeah.
Okay.
Yeah.
Thanks.
All right, last question.
Yeah, I have two questions quickly, just about the HPC. Like, what requirements do you have for the companies to get access to that? Are there any, do you have to do something for the common good? Does it have to be open source and so on? And about the data privacy of your data that you use, could you use sort of sensitive data on these machines? Is it somehow ensured that it's kept safe? Question to either one of you.
So basically, it's like that. On these machines, you usually have POSIX compliance, so you have user groups on Linux. If this is enough for your data, you can go for that. Otherwise, you would have to negotiate with the infrastructure provider to see if what they can do and how the data is protected. But that's the basic question. So there's usually no, let's say, isolation or network separation in the most common cases that I know. For the AI Factory supercomputer, this is a crucial question that you are thinking about how to solve that. There are certain ways to do that. And we're exactly thinking about maybe enabling the setup of the hardware in that way that you can really separate on network basis already, that the compute nodes are separated, and also down to the storage level to facilitate exactly needs for such cases. But one would have to look into directly how the system is configured and talk to the people there. And what was the second part?
The first part was like, do you have to are there some requirements that you have to reach to gain access to Leonardo, for example, or in the future the other one?
Okay. So basically, for this access calls, especially for AI, you need a VAT number. So you have to be a company and in the normal system. And they usually want to have at the end a kind of a report, and it should be kindish of open science. But usually you do some development, and you have to look a little bit in the preprint. Maybe talk to us later. But it should be open, and you should provide a kind of what you did afterwards, so that the joint undertaking can show what has happened with the computing time, basically. Yeah. Yes, but. We can talk later, maybe. Yeah?
Thank you.
Thank you. So it seems that we could go on with questions for another half an hour, but let's ensure that you have enough attention credits for the next talk. So thank you, Rank folks.
Thank you.
Thank you.
So our next speaker is Paul from Mostly AI. I have a special context with Mostly AI because my wife used to work there for a long, long time. So I'm very much looking for this talk because I know the amazing work that they do there. So Paul, the stage is yours.
It's great to be here. Cool location, cool audience, and cool previous talks. So thanks a lot for that introduction. This was really cool. So my name is Paul Thiewert, as Zoltan mentioned, and I'm working at Mostly AI. And I want to quickly refer to the previous talk of Mara and Ann-Sophie. So the AI Factory is a really, really cool project, at least in my interpretation, to speed up Europe's pace in what people call the AI race, right? So that's my short summary. And the cool thing, or one major thing that the AI Factory is achieving, is that it's providing compute to people, right? So essentially, you are democratizing the compute that's there to make it publicly available. Like we at Mostly AI, we kind of work in a complementary approach, so to speak, because our mission is actually to democratize data. Because there is compute, you need compute, but you also need data to extract information and to do cool stuff, and that's exactly the place that we work in. And obviously we want to make this responsible and in an ethical way. So when we talk about data democratization, we see the data democratization, two pillars we see there. One is data access. I think that's a pretty obvious one. And the second one is data insights. That might not be as obvious. What we mean there is, again, enablement, right? So we believe that there are so many smart people out there who
might not have a degree in math, in statistics, in computer science, and I think it would be super beneficial for speeding up innovation to also allow those people or enable those people to interact with data, extract insights that they could share in turn with the public. So in terms of tooling, I mean, you all know that LLMs are around, agentic AI is on the way, so there are tools that make that happen, so people can interact with natural language, with data, can extract models or insights, and so on and so forth. And we also have a little tool there. If you want to, you can check it out. It's essentially an LLM that is coupled to a Python shell, and it's really good at doing data science jobs, analyzing data, making nice plots, even train models, and so on and so forth. So if you are interested in such a tool, please go ahead, check it out. The second part and the main part of today's talk is the data access part and the synthetic data part. And that's exactly the place where it comes to the ethical and responsible part, because synthetic data, as I will hopefully convince you later on, allows for responsible data access while protecting the individual's privacy who contribute to that data actually. Okay, now let's dive a bit deeper. When talking about synthetic data, we see two major streams. I mean, you could slice up and dice up synthetic data in many, many different ways. I want to focus on two simple ones today. So the first one is, let's call it mock data, like low quality synthetic data. So what you start out with is your imagination, right? Maybe your specs from your database. You have tables in there. You have multiple columns in the tables, and you can describe them, right? Just with words. You put them together in a meaningful prompt. You send it to a generative model. In this case, an LLM. Maybe it doesn't even have to be an LLM, but some kind of foundational model. And what you would get out is mock data, right? So completely invented data, which, however, satisfies a certain structure, satisfies referential integrity, and also has some, meaningful correlation in there. And then the data, once it's there, it's ready for the downstream data consumers, which can be people, scientists, researchers, whoever, but also these days, obviously, algorithms and machines. And the use case is pretty clear, right? If you are a developer, you want to develop a pipeline for data or something, you don't have access to the data, you have to wait ages to actually get access. You can start with mock data, you have the specs, you create the data, you can start developing and reducing the time tremendously. The second approach, or the second synthetic data that I want to talk about, is what I call high quality synthetic data. So in this case, you start out from an actual database, so existing data, and what you do is you send these database tables into a generative model, which is trained from scratch. And on inference, you can create a synthetic version of your actual data. And when this is done right, the synthetic data is statistically representative. And ideally, when it's done right, the risk of sensitive information leakage from the original data to the synthetic data is minimized by a lot, right? Which means the synthetic data is safe to use. The synthetic data contains the statistical properties of the original data, but there is no individual information in the synthetic data that could leak. For both of those approaches, we have open source GitHub repos, which I cordially invite you to check out. If you're there, leave us a star, but maybe more importantly, give us feedback, right? So check out what you find, let us know what we could improve, and let us know what we might be able to add so that we might be, able to serve also your use case. So that would be very, very helpful. Now, to make that a bit more, tangible, let me do a quick demo of the mock case. When I find my mouse, there we go. So I prepared a very simple Jupyter notebook So I just import the mock library. I can rerun that. And then there is a config where you create or where you describe what kind of table to generate. So we want to create a table which is called guests, and it should contain the guests of an alpine ski hotel in Austria. And the columns should be nationality, name, gender, age, date of birth, and so on and so forth. So then you hit enter. The only thing you need to provide is do I have internet connection? Yes. So the only thing you need to provide is an API key for OpenAI or the provider of your choice. And then you get synthetic guests of this hotel. And you get nationalities, Austria, Germany, Switzerland, names, and you see that the names, there is a Lukas Bauer from Austria, a Hannah Schmidt from Germany, there is let's see, the Sophie van den Berg from the Netherlands. So you see it's meaningful data, right? It's mock, but it's meaningful. And you also see obviously that Hannah is female, Marco is male, Sophie is female. When you compare the ages to the date of birth, also that's more or less correct. So what I'm trying to say is you get meaningful mock data with basic correlations preserved. And again, you can do that not only for a table, but for databases, and you have referential integrity preserved. Okay, so that was the mock part. Now let's go back to the high-quality synthetic data part. And here, I would like to dive a bit deeper. So how do we actually create that synthetic data? Now, as a disclaimer, there are many, many methods out there how you can do it. You can use all kinds of models, GANs, VAEs, diffusion models, and so on and so forth. What we are using is what we term tabular ARGN or ARGN. It stands for Autoregressive Generative Networks, and it works like this. So imagine you have a 3-table data set, age, gender, and blood type. All those columns, all those features go into the network and are embedded. And once they are embedded, the information flow in the model is such that the output layer for column 1 learns to approximate the univariate distribution of age. So far, so good. The output layer of column 2 learns to approximate the conditional distribution of gender given age. And I guess you know what comes next. The output layer for the 3rd column learns the conditional distribution of blood type given age and gender. Very simple, very effective. One little thing that was bothering us, it feels a bit stiff because the column order is embedded in the architecture, right? So upon generation, you only could go, column 1, column 2, column 3, which limits a few use cases. So what we did is we came up with an any order version of that model, and the change was relatively simple. So instead of feeding the same order every time, we introduced a permutation layer, which kind of permutes effectively the column order during every batch or after every batch. So what this means in turn for the output layers, for all of them actually, but we are just looking at the one for column 1. This output layer now has to learn the univariate distribution of feature 1, the conditional distribution of feature 1 given feature 2, conditional distribution feature 1 given feature 3, and conditional distribution of feature 1 given feature 2 and 3. So with this, we can now, during generation, start with column 5, 3, whatever, any column order. The generation phase itself is super simple. You start out with a vector of zeros, essentially. You predict the distribution of feature 1. You do a random draw to actually realize a value. You feed that back, embed it, feed this information to the output layer of feature 2. You predict the distribution. You do a random draw, and so on and so forth. So what's actually happening is you autoregressively go column by column and generate a record, and obviously you do that batch-wise, and so you generate the synthetic data set. So there is autoregressiveness along the column direction or column domain. Now we can extend that to the time domain, and that allows us to generate sequential synthetic data. So imagine the patients that we had before with age column, age, blood type, and gender. They go to the doctors and visit doctors multiple times. So you have 1 doctor visit per row. Now, the model, in this case, when it tries to predict, for example, the distribution of the body weight at this point in time, so 4th doctor visit. So what does the model get as input? Well, it tries to learn the body weight distribution given date and blood pressure, which is the autoregressiveness along the column dimension. And it also gets an encoded history of all the previous doctor visits, right? And that's the autoregressiveness along the time domain. And that's not it, because in principle we can plug in any kind of context here. So we can also plug in the table that we had before, right? So the age, the gender, and the blood type of that specific patient. And with this kind of Lego brick system, right, we can build together even more complex, smaller databases and extend the autoregressiveness from the column level to the time domain to actually the table level, right? And that's kind of a little example of things that we can do. So you have patients, they have insurance claims, doctor visits. Every doctor visit can have 1 or multiple prescriptions, and then every patient can have lab visits, and so on and so forth. Now, also there, to make it a bit juicier, let's look at a little demo how this works in practice. Also that I ran before. So you import the Mostly AI SDK. You initialize it. You can say local is true, which means you run the whole thing like really on your machine. The alternative actually is you can also run in client mode and use our hardware, and also connect it to the platform, and then use the assistant and so on and so forth. And you see here my very old GPU, which requires me to run actually an older version. But yeah, so what we do is here we load a data set. It's the Titanic data set. It has 1,300 records. And then I start training the generator. And while the training is running, you see the progress in the Jupyter Lab. And okay, data is analyzed, data is encoded, works pretty quickly. And then training starts. And when the training starts, you get the epoch information, and the epoch with the lowest validation loss is highlighted, and you see the elapsed time, and so on and so forth. And this is running through. It will take about, I think, 40 seconds on my machine. And what the SDK also does is it creates the model report, right? So after every synthetic data run, you want to make sure that the synthetic data is of good quality. And synthetic data is of good quality when it represents the statistical information of the original data. So you get this model report. You have like overview accuracies, which are essentially composed, for example, of the correlations. You can compare original and synthetic data correlations in there. You see the difference. You see you can compare univariate distributions. You can compare bivariate plots, and so on and so forth. Now, what can you do? Did the training finish? Yes, training finished in 40 seconds. Now, what can you do? Well, once the generator is trained, as promised, you can generate synthetic data, right? And the beauty, or one of the beauties of synthetic data is you are completely unlimited by the sample size. So you saw the original data set had 1,300 records. Now I probed the generator for 1,000 records, and I hit enter, and boom, I have 1,000 synthetic passages of Titanic. Another thing that I want to stress, because it unlocks a lot of features, is conditional generation, right? So again, we can swap columns around, and we can say, oh, I want to provide a seed, right? So you can say, in this case, I want to create more female second-class passengers who embarked from S, which I guess stands for Southampton. So what you do is you create a seed. Sex is female 10 times. The class is 2 10 times. Embarked in S 10 times, and you run that, and you have 10 female passengers who embarked from Southampton. And again, you could generate millions if you like and if you need to. Now, why am I stressing that? The conditional generation, as I said, allows for certain applications. One of them is, for example, rebalancing. So in some setups or in some scenarios, it is possible to take your data set, you have a minority class in there, which you then can scale up, right? And when you do that, you have a synthetic data set, or you can even mix the original and the synthetic data set. You scale up the minority class, and again, in some settings, not all the time, it has to be specific, you can see quite an increase in the performance of your downstream model on original data. And if you want to, actually, there is a collab where you can run this code if you like so. Another feature that's super interesting that we try to push more recently, that's also based on conditional generation, is what we call simulation with synthetic data. Because in a way, imagine you train a sequential model, a sequential synthetic data generator. What you effectively have is a model for time series forecasting, right? And again, you can provide seeds, which means you can provide history. And yeah, those are just some examples we did internally. So this was our CTO did a decathlon, and he was searching for historic decathlon data, and he trained a generator on that. And then in this simulation, we kind of simulate the outcome in terms of total points based on actuals of the first 1 to 9 disciplines in the decathlon. And you can see curious or interesting things because obviously the models are probabilistic. You see a distribution, you can do estimates, quantiles, blah, 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 this and that. And the model learns pretty well. So for example, after 3 iterations, it essentially hits the mean outcome perfectly well. And maybe in a more business oriented scenario on the right-hand side, what we did there is we took the Rossmann data set and we, for example, fed 2 weeks. So those are 2 weeks as history, and then you can simulate, potential outcomes in terms of the sales that a store is making or the number of customers that a store is visited by, and you can look at the distributions and you can do things like, again, value at risk, calculate quantiles, and so on and so forth. And additionally to that, you can check policies, right? So you can, I don't know, so in the Rossmann data set, there is a promotion column, so you can test different promotion schedules, for example, things like that. So simulation with synthetic data. However, looking at the time, as I advertised before, right, the main use case of synthetic data was for a very long time and still is the data access and the data sharing, the data privacy use case. And here I would like to share some highlight use cases that we, our customers came across or are doing over the time. So one is coming from a German telco, and they put the know your customer approach to an, let's call it extreme. So what they did, they created a synthetic version of their customer base and then provided to the whole company a dashboard that allowed everyone from the intern to the CEO, to slice and dice the data, basic data of their customers. So internal data sharing. Another use case from the Swiss Postal Service, they offer a product which is called, I don't know how it's called, but it's actually, so for example, an NGO could approach them and say, we have a budget of 30,000 euro and we want to do a direct mail campaign. So where could we send those letters to? And what the Swiss Post is doing, they search, I think, zip codes, regions where they believe that people live that are most susceptible to this type of advertisement. And what Swiss Post did, they created a synthetic version of Switzerland and used this synthetic version of Switzerland, of the Swiss population, to actually find regions that this NGO might want to send their letters to. Now come the use cases that are actually dearest to my heart because they are from public entities and really, you know, are in the line of public data and public data sharing. So one is from the Moderate Consortium, and maybe there is someone actually here because there are people in Vienna working on that, or at least in the consortium. And this is a completely different sector. It's the energy sector. And if I understood everything correctly, so in the Piedmont, there are buildings, I guess you know that, and every building has an energy performance certificate. Now, those certificates are super interesting, right, for stakeholders in the energy sector. However, they are in the possession of not the public, but the government essentially, right? And they cannot be easily shared because it's private data. So what the consortium did, they created a synthetic version of the buildings in the Piedmont, and then they created this dashboard which is open to the public. So again, people can check. There are also maps there, how buildings in different regions in the Piedmont behave, and people maybe also people who build houses can go there and inform themselves of what to do. And last but not least, the most recent one that I want to share, it was actually also on OF Wien, was a study done by the I forgot. I will mention that if it comes to mind. It was done on the who lives where in Vienna and which ethnicities populate which areas of Vienna, and the researchers were able to do that on a very small granular scale. And I actually checked back what the real benefit of synthetic data was, and this is really also kind of time to data, because they said they could do this on the original, but it would A, be much more costly, and B, it would take much longer, and it's much harder to work with the data. So looking at the time, I will stop right now. Thank you very much for your attention. I'm very happy to answer any questions that you might have. Thank you very much.
Thank you, Paul. There is time for questions.
Hi, thank you very much for talk. I wanted to, you highlighted that privacy is one of the main reasons for synthetic data. How do you actually measure if the synthetic data set is private, and how to ensure that? Do you use additional tools for that? Or not?
So there is, I could give another, a couple of hours talk on that. I tried to compress it. So there are different levels, right? So one level is that you say, okay, we do like basic privacy protection mechanisms like outlier, clipping away, stuff like that. We run through the anyway very noisy training process, and then you check the models, or actually, check the model in terms of privacy by things like membership inference attacks, where you really compare, for example, you train a data set, you remove a single record. So you create a synthetic version of a data set, then you create that synthetic data set again, but you remove one individual from the training, and then later on you try to learn something from that individual, right? So you really compare and see how much the presence of that the single individual changes the outcome of the synthetic data, right? So that's one, let's say. That's an empirical approach of measuring it. So I mean, you can do very basic things. You can stop the training more early. You can make the clipping more extreme. But let's say the gold standard of privacy is differential privacy, where you have a mathematical guarantee, an upper limit for the information that can leak by exchanging a single person. So what you can also do with the SDK is you can switch on differential private training, which essentially what it does, it takes the gradients, it clips the gradients, and adds random noise on the gradients. And this gives you a guarantee. Yeah, and if you see, there is too much information leaking, you can crank up that noise. Yeah.
Yeah, thank you, Paul. That was a great talk. I appreciate that you opened the question of data representativeness, which is the fundamental aspect of data science. I'm really curious about following, if I got it correctly. So you're claiming that on one side, you might have a small sample, which you don't know how representative it is. And building predictions based on that sample might not be the best approach. So you say, okay, we multiply this small sample of unknown origin, we scale it up with synthetic approach, which sounds robust to me, but then you claim that these models that you train on the synthetic data set actually delivers better predictions in the production. I mean, not on the same data sets you generated, but literally in the production. Is that correctly?
I try to be careful with what I was saying. So it depends on the setting, right? It really depends on the setting. The scenario where we saw that effect. So like one statement or disclaimer right up front. So synthetic data cannot invent new data. If you don't inject additional information, there is nothing synthetic data can add, right? If you don't do that actively. So the cases where we saw that were structured the following way: you have a data set, you have a minority class, which can be really small. And then when you scale up, we compared, for example, to different methods like Smolte or dumb rebalancing, like just duplicating the minority class to help the downstream model. And their synthetic data helped because it added more diversity, right? It made the model more robust, I would say, and it was able to kind of, I guess, infer from the information that it learned from the majority class how to, let's say, interpolate maybe more clever than Smolte does, right? Which is just a linear interpolation in the feature space. So that's the setting where this works, where kind of synthetic data adds more diversity and thus a bit more stability to the model. But like the margin is relatively slim, I have to say. Yeah.
Yeah, interesting. Thank you.
Yeah, just a quick one. I think just touching on and picking up from the two questions that have already been raised, concerns of privacy, of course, and in terms of diversity. One thing in terms of the privacy, I can understand synthetic data would be actually useful when you have investment banks and organizations like that take actually biometric data before starting a job. I know because I've worked there and I have clients there. So there is biometric data, so I can see the issue of privacy here. And for many people in human resources who I also have clients, that is the reason why many of them have concerns about adoption. So synthetic can be useful. The problem you also have is, as the gentleman just asked, you can't just add on diversity as such, because AI already comes with its own algorithmic and other biases. And so if you're building on that, you remember there was a time that one of these companies tried to go the other way and they overweighted, and things like that. How are you going to get around that? Especially we have the EU AI Act coming up, where a lot of HR systems will be classified as high risk, biometric systems coming up. Where do you come in as synthetic?
Yes. That's a good point. Let's put it this way. We have some levers. There is no like recipe, you do this and you are safe. We have some levers. But you're right. Like if you don't do anything, what you put in is what you get out, right? If you have statistical representativeness. So one piece of work that we did was on fair synthetic data, where we tried to embed statistical parity. Like fairness is on a different level than privacy, even more complicated, contradicting definitions, blah blah blah, this and that. So we tried one of them. And because we operate really on the level of conditional probabilities, we have access to them, so we can modify them. The big question that is unsolved is modify to what? To what outcome, right? So we have a tool because, as I said, right, the model can estimate all the conditional probabilities, so we could tweak them. The big question is, to what end and to what outcome, right? So with statistical parity, it worked. We could show, okay, you create statistical parity, you train a downstream model. The downstream model preserves statistical parity, even if it's trained on original bias data. So that was one thing we did, but this is definitely an open and interesting question, how to proceed there. Yeah.
It comes back to human in the loop. I mean, that's one of the things. Yeah.
But the AI doesn't come trained. It's pre-trained by humans.
Yes.
With their biases.
Exactly.
Yeah.
Yeah.
So you're answering my question. So you've answered my question.
Yeah.
Exactly.